Hi everyone, this is the second notes for probability. These notes are focused on two very specific type of situations called combinations and permutations. So I put them side by side so you can see the clear difference between them. And so let's get started with the definitions. A combination is an arrangement where the order is not important. And what do I mean by order? As in putting stuff in order. Example, picking 3 winners. Now, this is just saying, like, I just need 3 people to win. It doesn't matter what order you win in, but there's going to be 3 winners, okay? And so a permutation is an arrangement where the order is important. This one is important. What's the example? For this one, it would be like if I was picking first, second, and third place winners. And this is different because first and second place are not the same. The order does matter. So that is the difference between a permutation and a combination. And so let's practice first identifying if we can decide whether the scenario is a permutation or a combination. Again, combination means it doesn't matter. We just need X amount. And permutation, it does matter. I need them in the specific order for the list, okay? So, number 1, grouping 5 students to work on a project. What do y'all think? Do you think the order matters if I group 5 students to work on a project? Does the order matter? No, it doesn't. So this is a combination. We're just going to put C. What about arranging the letters in the word geometry? Does the order matter? Yes, the order does matter in order to spell the word geometry. So that is a permutation. All right. Being dealt 5 cards from a deck of cards. So this is like if we were going to start playing a game and everybody gets 5 cards. Does the order matter of the cards that you get? No. You're just given 5 cards. Okay. Giving out bronze, silver, and gold medals at a race. Does the order matter? Yes, of course. Each one is a different place, so that's permutation. Forming a committee with teachers and students. Forming a committee with teachers and students. Does the order matter? Not really. I just need to know that they're teachers and students, but the order doesn't matter. What about choosing toppings for your pizza? Now, the key word here, this one's a little tricky because obviously you put the sauce first and then the cheese and that, but that's not what it's saying. It's just saying you're choosing toppings. When you're choosing toppings, it doesn't matter what order you choose them. No, so that's a combination. What about inputting the code for a lock? Of course, if you don't put the right code, then it won't unlock. So the order does matter. So that's a permutation, okay? Now, what is the point of all this? We're going to be calculating right here, all the different combinations and orders that we can do stuff. So for combination and permutation, there is we're going to be using the calculator to find that number. And so you got to get familiar with the format for combinations and permutations. Now, the only difference for these two are that obviously this is a combination and this is a permutation. But the N represents the total. So like how many you have. And then R represents the number that you want. Okay, and we'll see what that means right now. So when doing these problems, you have to make sure you know which one's which. Who's the total and who's the number wanted. And an R. And then I'll show you how to do that on the calculator. So let's do these examples together. How many different batting orders are possible if there are 15 players on the team and there's 9 players in a lineup for a baseball team? All right, so first we need to decide, does the order matter? Does it matter what order they're in? Technically, yes. For baseball, the order does matter. Believe it or not, teams have a specific order to put players in for different scenarios, better chances of winning, etc., etc. And so the order of the lineup for a baseball team, it does matter. And so this is a permutation, not a combination. All right, now we need to decide who's the total and how many and who's the number wanted. There's 15 players on the team, so that's the total. That's N. And there's 9 players in a lineup, so I only want 9. That's the R. Okay? And if we set up the right formula, that would be 15 permutation and then 9 players wanted. Okay? And then do y'all see the formula up here? And then you do parentheses and you put the numbers again. 15 first and then 9. And you're going to separate the numbers with a comma in between. So write that down correctly while I open up Desmos. Okay, so when we go to Desmos, I need you to watch clearly. You're going to go to this part of the calculator where it says function. And you're going to see it down here on the bottom left that I have it. NPR. You're going to press that button. It's going to open up the format for you. And then your numbers are 15. So 15. And then you need a comma. So if you don't see the comma, it's right here under tangent. Comma and then 9. Okay, and then you close the parentheses. So make sure on your calculator it looks like this. All right. And so my total is a very big number. So you know what? Let's change the number 15 to 10. I'm so sorry. Change the 15 to a 10 on your notes. 10. Because that number is too big. Okay, make sure you tell everyone we changed it to 10. Yeah, that number is too big. Sorry. Okay, yeah, that's better. So when you change it to 10, here's the different orders we could have it in. So that's equal to 3,628,800. Lots of options. Okay. All right, don't forget we changed the 15 to 10 right here. 10 players. And then 9 on the lineup. All right, let's do the next one. At Domino's, a special combo pizza includes 5 toppings from a list of 16 toppings. Does the order matter if you're just picking your toppings? No, because Domino's is just going to look at what toppings you order and then they're going to make your pizza. You just need to pick 5. So the total is 16. So 16 is the N. And I need 5. So 5 is the R. Okay, and we said the order doesn't matter. So this is a combination. NCR equals 16, comma 5. Okay, and then let's see what number we get. So go to your calculator, main menu, change it to function, and then NCR is right here. And then it is 16, comma 5. Like so. Okay. I'm showing you how it's supposed to look because this is the way we're going to be doing all these problems. All right, so my answer is 4,368. Those are all the different pizza topping combinations you can do if you're ordering 5 toppings. Okay. All right. Next one. A grocery store sells 7 different flavors of cheesecake. You're planning to buy 2 cheesecakes. So, does the order matter? No, you just want to buy 2 cheesecakes. But they're telling you there's 7 options, 7 flavors, and you want to buy 2. So, this is a combination. Okay. Who is the N? N is the total. Who's the N? 7 or 2? There's a total of 7 flavors. So, N is 7. And then you only want 2, so that's the R. So 7, 2. Okay? All right, and then let's go calculate what that will be. So I'm just going to delete this. Okay. 7, 2. All right, let's see what number we got. There's 21 options. Combinations of cheesecake that you can get if there's 7 flavors, but you want to buy 2. Okay. All right, number 4 says 10 students are auditioning for the roles of Gabriella and Sharpay in High School Musical. And that's all they say. So obviously we need to fill the roles. There's only 2 roles to fill in this scenario. Gabriella and Sharpay. So that's 2 roles. So the number you want is 2. And how many students are auditioning? 10. So there's a total of 10 students, but I'm only going to pick 2. So does the order matter? This is a tricky one. Yes, the order matters because there's 2 different characters. And so this is a permutation, actually, not a combination. Because one girl can be casted for Gabriella, but she could also be casted for Sharpay. So the order matters. Okay. All right. And then so that's going to be 10 and 2. Okay. All right. Let's see what we get. Let me clear this. So NPR. 10, oops. Oh, what am I doing? 10, 2. Okay. There. All right, let's see what the possibilities are. 90 different ways that 10 people auditioning could be casted for Gabriella and Sharpay. Okay. All right, last one. John has 6 different flags that he wants to hang on the wall. How many different ways can the flags be arranged in a row? Okay. John has 6 flags. He wants to hang them on the wall. How many different ways can it be arranged? Okay, so obviously the order matters because they want to know different ways to rearrange them. So one could be in one spot, the other one could be in another spot, and vice versa. We want to know how many different spots they could be in. So yes, the order matters. So this is a permutation. How many total flags is there? He has 6. So N is 6. And how many outcomes can we have? How many do we want on the wall? Well, he wants to hang all of them on the wall, but he wants to know how many different options. So the number wanted is also 6 for both. Okay? That one's a little tricky. Make sure you write it down. I'm sure you're going to see that on your Delta Math. So, all right, so the both numbers are 6 for that one. Like so. Okay. All right, so he has 6 flags and he wants to rearrange them in 6 different ways on the wall. I mean, he wants to have 6 flags on the wall. So there's 720 ways to rearrange them. Okay. All right, and that's it for combinations and permutations. Remember, the first step is to decide, does the order matter? So go ahead and log into your Delta Math. Do not lose your notes and use a Desmos Scientific. Thank you.